Hi, this is part 3 of our physical quantities review. We left off our last video talking about force, which we remember, as you recall, is force equals mass times acceleration. Pressure is very closely related to force and is one of the most common measures we use in the field of speech science. Pressure may be expressed as either E or P depending upon the conventions of a specific discipline. And it is actually force. The pressure is defined as a force that is distributed over an area. And the units that are typically used for pressure are units such as Pascal in the SI system. In speech science, we often use micropascals, which are millions of pascals, and that's because we use that kind of measure to measure sound pressure. And sound pressures are rather small. There are other units for pressure units. Sometimes we will use units such as centimeters of water, and that really defines the amount of water that is displaced by a given pressure. Barometric pressure is measured in millimeters of mercury. How many millimeters of mercury are displaced by a given air pressure. So there are a variety of different ways of measuring pressure. The differences between force and pressure are ones that shouldn't be overlooked. And this example here, I think, demonstrates it well. If you have a given, remember, pressure is force over a given area. So we have our force vector here expressed as an arrow, where the length of the arrow and size of the arrow expresses its magnitude and the direction of the arrow its direction, and it's applied across this given area. And so this is going to yield a particular pressure. Now let's say that we change one of the parameters of the equation. If we apply the same force but to a smaller area, the denominator is going to get smaller, and therefore the value of pressure is going to get larger. So if you apply the same force over a smaller area, you're going to be applying a greater pressure to the system. Alternatively, if you leave the area the same and increase the magnitude of the force will be larger, the numerator will be larger, and you'll also increase the pressure. Decreasing pressure, you could just do the opposite. You can either increase the area for a given force or decrease the magnitude of a force over the same area. A great example that's of understanding the difference between force and pressure is is how the operation of a thumbtack, or how a thumbtack works. If you think about it, you have a large head of the thumbtack, which has a fairly large area, and then you have the tip of the thumbtack, which has a very small area. If you are pushing your thumb on the head of the thumbtack, you're applying a given force to that large area. The resultant pressure on your thumb is not very large. However, that force is transferred through the thumbtack to a very small area. As a result, the pressure at the tip of the thumbtack is very, very high. And so we use the design of the thumbtack to minimize the pressure exerted on our thumb and maximize the pressure exerted at the tip, so that it drives the thumbtack into a board or cork board, tack board. Now work is a fairly simple idea. It is the amount of force that is applied over a given distance. So work equals force times distance. And you can get this idea if you just think about having to apply force to push a box down a hallway. And if you push that box further down the hallway, you will be doing more work. If you take a bigger box that requires more force to move it, and push it down the same distance, you will then apply even more work. So work itself is a measure of force times the distance over which that force is applied. And typical units are joules in the SI system, or you'll see ergs and foot-pounds, and you sometimes see these as representations on physical fitness equipment that give you estimates of how much work you've done during your exercise regime. Power refers to the rate at which work is done. So it is work per unit time. If we go back to our analogy of pushing a box down the hall, you can push that same box, apply that same force for a given distance. You can do it in 1 minute, or you can do that in 30 seconds. And obviously, when you push it in 30 seconds, the power required to perform that task is going to be greater. The reason we even bring in the concepts of work and power is that we don't use these units or these measures very much in speech science, but it provides us with an opportunity to get to an important measure, which is intensity. And intensity is the area over which a power is focused. So if you look at the equation here, intensity equals power over area. It looks somewhat familiar, doesn't it? Because pressure equals force over area. So intensity is to power what pressure is to force. It's a very similar kind of idea. And the reason that I bring this up is that we do use measures of intensity. We use intensity as an estimate of the size of sound waves, as a measure of magnitude of sound waves. Two main ways to measure sound is intensity and pressure. Intensity units are typically things like watts per centimeter squared. And intensity is a term that we will return to when we start talking about the decibel system. Finally, I want to just briefly touch on the concept of resistance. Resistance really is a measure a ratio measurement that expresses how easy it is for something to pass through a system. In the electrical world, resistance is defined by Ohm's law, where resistance is equal to the voltage over the current. We don't do a lot of electrical circuit analogs or anything like that in speech science this semester, although many of you may have had it in the past, and it is a useful information to have. We'll often talk about resistance in our class as it applies to what we call acoustic or aerodynamic resistance, which is a ratio of pressure over flow. And the best example I can provide for this is the relationship between the pressure and flow of a garden hose as you very squeeze on the hose itself. You think about a garden hose that has water coming out of it, and you pinch that hose. What you're going to do is you're going to apply a buildup of pressure in the hose and reduce the flow. And since pressure is on the numerator and flow is on the denominator, pressure will be higher and flow will be lower, resistance will be high. Now if you then unpinch the hose, flow will return to a higher level, pressure will be reduced, and you'll end up with a lower resistance. In the speech system, we often are interested in resistance at key structures within the vocal tract, like, for example, the larynx. What is the laryngeal resistance to airflow? That's just a brief overview of the key aspects of quantitative measures that apply to the speech science course.